This is lesson 2.5, the zeros of a quadratic relation. You should have this handout in front of you. If you don't go grab it from the teacher at the front of the room. Okay, so this is what we're doing in this lesson. We've just done 4 days of factoring. You're now expert factorers. The whole reason why we're factoring is because we want to be able to take something from standard form and be able to come up with the zeros or the roots. So for example, if I give you this function, let's say, okay, so we know that that is an expanded form or standard form. If we take a look at these over here, we know that there are 3 forms of a parabola. So far we've only dealt with standard form. So now what we're going to be looking at is factored form. So if we have something in standard form, and my question to you is, can you find the zeros or can you find the vertex? The first thing we need to be able to do is factor it, because when I say find the zeros, I'm really just saying find the x-intercepts. And what that means is that y, or f at x, equals to 0. So when I plug in f at x equals to 0 here, I'm still left with this equals x squared plus 3x plus 2. And I can't solve for x because of this guy right here. Because of this squared right here, I can't solve for x. So that's why we learned how to factor. So what I would do from here is we would say 0 equals, well, what are 2 numbers that go into, that multiply to 2 and add to 3? Well, that's 2 and 1. So we'd factor this like x plus 1 and x plus 2. And now if I said, what are the zeros? This is easy for you because we're just going to ask ourselves, what would have to go in here? What would x have to be to make this whole equation equal to 0? Well, you'd say that x has to be -1, and over here x has to be -2. So we would write our first 0 is -1 and our second 0 is -2. So we actually have a equation of quadratics that's going to represent that. Okay, so let's get started on the first question. So the first question says, it's giving us, let's see if I can use this highlighter. Okay, so it's giving us the factored form of a parabola. And remember that there are 3 forms or 3 equations of a parabola. We've got factored form, which we're going to deal with now, standard form, which we know a little bit, and vertex form, which we're going to do in the next unit. Okay, so let's go to factored form. We've got an A, an S, and a T. All you need to know right now is that S and T are x-intercepts, okay? So there are either 2 x-intercepts, 1 x-intercept, or no x-intercepts. So without knowing anything else, can you read off right here which are the x-intercepts? So you're going to ask yourself, if f at x was 0, what does x have to be? Let me get my pointer out. Okay, so if f at x is 0, what does x have to be to make this entire thing equal to 0? Well, wouldn't x just have to equal 4? So our first x-intercept is 4. And now, take a look at this next one. What does x have to be here to make this whole term equal to 0? So wouldn't x just have to be 9? So our second x-intercept is 9. So we've got 4 and 9. So now to figure out what A is. So take a look at the factored form of a parabola, okay? So A is just defined as whatever constant or coefficient is being multiplied against the 2 brackets. So take a look here, and we've got, what is A along here? Clearly 2 is A. So instead of A, we're going to write 2. So we've got 2 here. Okay, so we've got A is 2, S the first x-intercept is 4, and the second x-intercept is 9. Let's do the exact same thing here, and let's try to look for a pattern. Okay, so we're going to look here. What has to be the first x-intercept? Well, if I set y equals 0, what does x have to be to make this whole thing 0? -8. And how about this guy? What does x have to be to make this entire thing 0? 3. So these ones are pretty easy. So our first x-intercept is -8. and our second x-intercept is 3. And what is a? Don't forget, a is just whatever number is being multiplied against the two brackets. Here, what's that visible number? It's -1. So we've got a -1 here. Okay, let's take a look at the next one now. Okay, this one looks a little bit different, but we can do it. Okay, so let's pick out the x-intercepts here. What does x have to be here to make this whole thing equal to 0? Well, x just has to be 0. How about this guy over here? What does x have to be in this term to make this term equal to 0? If you said 3, you are totally right. So I'm going to put 0, and I'm going to put 3. And now, what's a? A is clearly 6. Okay, so I've got the chart filled out. Now in this question here, it's actually asking for us to come up with the equation ourselves. So it's giving us a, it's giving us the first x-intercept and the second x-intercept. So can you come up with an equation? So this is what I want you to do is pause the video and try it yourself, and then check your answer by pressing play. Okay, so if you're checking your answer now, make sure you've tried it on your own. Here's the right answer. So you should have a function, f at x equals, our a is 1, so I can just put a 1 here, or I don't have to put anything, in brackets. If our x-intercept has to be -2, that means that it should look something like this. Because if I were to solve this backwards and say, what does x have to be to make this whole thing 0? The answer would be -2. So here we're coming up with the question and it's giving us the answer. Can you do the same thing for 1? It would look like this. X minus 1, boom. Okay, so why is this correct? Well, you can ask yourself, what does x have to be to make this whole thing equal to 0? Well, x has to be 1, and there's 1. So there is another way to look at this factored form of a parabola, which is just to look at s and t as the x-intercepts. So let's take a look at the questions we already did so you understand what I mean. Take a look at this one. S and t are the x-intercepts. So you might be saying, well, it looks like -4 and -9 are the x-intercept, but it's actually +4 and +9, which is true, but take a look at what s is defined as. S is defined as whatever number is beside the negative. So what is beside the negative? Well, it's going to be the opposite of -4. It's going to be +4, and that's how we got that. So we got it by asking ourselves, what does x have to be to make this whole term binomial equal 0? What has to be 4? Another way you can think of it is that the x-intercept is s, and s is defined by whatever is beside the negative, and the second x-intercept is t, and that is defined as beside whatever the negative is. So here, the x-intercept would be 4 and 9, because those are beside the negative. 4 and 9, boom. Let's take a look at this one. What must have been here if there is a plus? Let's just take a look at this. So I'm just going to pull this guy out, and I want to just talk about it for a second there. If it looks +8, then what must, if I'm forcing myself to put a negative here, wasn't there must have been a -8 here. Sorry, that's a silly 8. Here we go. So this is what the equation must have been. So if we are defining our x-intercepts as whatever is beside the negative, what's truly beside the negative? It's -8. So that's where we got -8 from. Or you can always just go back to our regular method, which is ask yourself, what does x have to be to make this entire thing equal to 0? -8. Another way to think of it is you can always just take the opposite of whatever is there. So there's lots of different ways that you can think about it, okay? So s is defined as the x-intercept. S is whatever is beside the negative. T is also the second x-intercept. It is defined by whatever is beside the negative. So if we're going to do our next one, so here we've got our answer. We're going to come up with a question. What must the equation have been? Let's try plugging in a, s, and t right into our equations and solving. So we have, okay, so we're going to have f at x equals, our a is -2, so we're going to write -2. Our x, Where is this? Okay, so our first x-intercept is 0. So we're calling this s. So instead of s, I'm going to write 0. And instead of t, I'm going to write 2. So I'm going to rewrite this as x minus 0, x minus 2. So we know that x minus 0 is just x. So I'm going to rewrite this one more time. And I've got f at x equals negative 2 times x minus 2. And that's my final answer. So if we were doing it our other way, which is just asking yourself, setting x equal, or f at x equal to 0, and asking yourself, what does x have to be to make this equal to 0? We would get the answer 0. So we've got this right. And if I ask myself, what would x have to be to make this term 0? It would be 2. So we've got this right. So use whatever method makes sense to you, as long as you understand that s and t are the x-intercepts, and it's defined as whatever is beside that negative sign right there. Okay, so let's keep going down the sheet here. Okay, so we've got this equation. Here is one of the equations of a parabola, so factored form. So let's just remind ourselves of what each of the letters mean. So we talked about S a lot, we've talked about T a lot, we haven't talked a lot about A. So let's talk about S for a second. S and T tells us the first x-intercept. Sorry for my writing, it's hard to write on this thing. And T is going to tell us the second x-intercept. Order's not important. Okay, so what does A tell us? This guy over here. Okay, so we're going to go into a lot about A in the next unit, but for now, all you need to know is that when we have a parabola, we've got two different types of a parabola. We have a parabola that opens up, and we've got parabolas that open down. So if you were to guess, if A is positive, what do you think? Is it going to open up or open down? If you said opens up, you are completely correct. So if A, this guy right over here, is positive, we know that the parabola opens up. Parabola opens up. And if A is negative, the parabola is going to open down. The parabola opens down. All right, so we got our three letters down. We have, when A is positive, we know the parabola is going to open up, and when it's negative, it's going to open down. We know what S is. S is the x-intercepts. We have all these different techniques for being able to find it. And T is the other x-intercept. Are we ready to move on? I think you are saying yes. So go on to the next bit over. Okay, so really quickly, let's just summarize. Can you pull A, S, and T very quickly? I want you to try this on your own. So pause the video, fill it out, and just check your answers. I'm going to go through them really quick. So pause now. Okay, so if you are playing this video, that means you have everything filled out and you're just checking your answers. So I'm going to do them really quick. A is clearly 2 here. I'll just write the factored form up here just as a reminder. F at x equals A, x minus s, x minus t. Okay, beautiful. So whichever method you take, if you figured out that s is 4, you are totally right. And if you figured out that t is 9, you are also totally right. Just a quick recap. 2 ways you can do it. Ask yourself, what does x have to be to make this guy equal to 0? Answer 4. Same with here, answer 9. Another way to think of it is s, our 0, is defined by whatever is beside that negative. What's beside the negative? It's a 4. What's beside the negative? It's a 9. Another way to think of it is take the opposite of that number. Opposite of negative 4 is 4. Opposite of negative 9 is 9. Okay, so the zeros are x1 equals 4 and x2 equals 9. What is our vertex? Can you remember this from a week ago? Well, just remember the parabola. If our first x-intercept is at 4 and our second x-intercept is 9, and we know that this parabola is going to open up. We know that direction of opening is definitely going to be up. So it's going to look something like this. How do we find that vertex? Well, the first thing we need to do is we need to find the middle point. We need to find that axis of symmetry, and then we can solve for the y. So let's do that axis of symmetry really quickly. So it's going to be x equals, just find the average, 4 plus 9, that's a plus, all divided by 2. X equals, so that's going to be 13 divided by 2, which is 6.5. And as I write 6.5, I realized I made a silly mistake. I said this parabola opens up, and what did I do? I made it open down. So make sure that this guy actually opens up. Okay, so it's going to actually look something like that, okay? Okay, so we have not found the vertex yet. We found the x coordinate of the vertex. What do we have to do to actually find the vertex? We're just going to plug that in to our original equation right over here. So instead of x, I'm going to write 6.5. Instead of x, I'm going to write 6.5. And you're going to solve, and you're going to find that y equals, okay, we got negative 12.5. So I don't have room to write it here, but you might have room. The vertex coordinate is 6.5 comma negative 12.5. And that makes sense because it opens up, that vertex should be negative, so negative 12.5 works. Let's do this other one. So you should have A, S, and T all done. Our A is negative 1, our S is negative 8, and our T is 3. Okay, let's find, what are the zeros? The zeros are clearly x1 equals negative 8. And our x2 is going to equal 3. Okay, let's find the vertex. We know this guy is going to open down. Our x-intercepts are negative 8 and 3. So it looks something like that. Okay, let's find our vertex by first finding the axis of symmetry. So let me pick a different color here. We've got x equals, let's find the middle point of negative 8 plus 3, all divided by 2. And we've got x equals negative 2.5. Okay, so to find the vertex, we're just going to plug that guy in to our equation. So right over here, I've got negative, instead of x, I'm going to write negative 2.5 plus 8, and then negative 2.5 minus 3. And we've got y equals 30.25. So our coordinate of our vertex is negative 2.5 comma 30.25. The direction of openings, because our A is negative, this must open down. Okay, so here we've got our conclusions. You can read through them. We've gone through them a ton. Let's keep on going down. So we have, I think, 2 examples left. So we are given that the zeros of our parabola are negative 3 and 5. The parabola crosses the y-axis at negative 75. What is the equation of this quadratic function? Well, the only equation that we really know other than standard form is factored form. So let's just write that out. So we're going to start off with the equation. So f at x equals a x minus s, x minus t. Okay, so we know that what our 2 zeros are. Our 2 zeros are negative 3 is s and 5 is t. So instead of s, I'm going to put negative 3. Instead of t, I'm going to put 5. And I have no idea what a is yet. So I'm going to rewrite this as f at x equals a x, copy the minus, and then write your 0, which is negative 3. And then again, x, copy the minus, and then we're going to write our other x-intercept, which is 5. Okay, so let's simplify this. We've got f at x equals a x plus 3, x minus 5. The one thing that we need still in this equation is a. Think of this like y equals mx plus b, just as a side note. When we were solving for y equals mx plus b, all we had to do was find m and we had to find b, and then we were done. So now, as I get rid of this, okay. Now what we need is we need a, we need s, and we need t. We have s, we have t, we need to find a. So what we're going to do is we're going to use the other piece of information that we're given. We're told that the parabola crosses the y-axis at negative 75. What we're really given here is a point. We're given the point 0, we're given the point 0, negative 75. So what we're going to do is we are going to plug in this point, plug in the point 0, negative 75 in for x and y, or in our case, x and f at x. So that's what I'm going to do. I'm going to rewrite this guy, and instead of f at x or y, I'm going to put negative 75, and instead of x, I'm going to put 0, and then we're going to solve for a. So we have f at x equals, oh, sorry, I'm going crazy. We're replacing f at x. Let me erase that. Okay, so instead of f at x, I'm writing negative 75 equals, I have my a here. Instead of x, I'm writing 0. So I've got 0 plus 3 and 0 minus 5. So let's solve this thing. We've got negative 75 equals a. 0 plus 3 is just 3. 0 minus 5 is negative 5. I can keep on simplifying. Negative 75 equals a. 3 times negative 5 is negative 15. Okay, so to get rid of this guy, I got to divide by negative 15. Divide by negative 15. Cross it, cross it. And we have that a is going to equal positive 5. Okay, box that guy, and let's make a final equation. So now we have our a, check, our s, and our t. So here was our s and our t. So let's throw that back in, and now we're going to replace it with our a. So we are going to write, our final equation is f at x. Instead of a, I'm going to write 5, and then we have x plus 3, x minus 5, big box, and we're good to go. The last question, B now says, what are the coordinates of the vertex? Okay, we can figure this out. Our x-intercepts are negative 3 and 5. So I've got negative 3 and 5. This problem is going to open up because, take a look at our a. Our a is positive, so this problem is going to look something like this. Okay, so let's just find that axis of symmetry, and then we can plug it in. So our axis of symmetry, x equals, just find the average, or the middle point of those two zeros. So we've got negative 3 plus 5, all divided by 2. We've got x equals, we've got x equals 1. Okay, so we know that this part here is 1. So what I'm going to do is I'm going to plug that into my equation and see what pops out for y. So here's my equation. So that's what I'm going to write. So I'm going to write f at, instead of x, I'm plugging in a 1. So f at 1 equals 5 times 1 plus 3 times 1 minus 5. And I've run out of rooms here, so I'm just going to continue over here. So that's going to be 5 times 4 times negative 4, which is going to equal negative 80. So our vertex is going to be, our x is 1 and our y is negative 80. So our vertex is going to be positive 1. Sorry, that's, okay, our vertex is going to be positive 1, negative 80. Boom, all done. Okay, let's move on to the next problem. So flip to the next page. This problem is exactly like the one that we just did, so try this one on your own. Pause the video and check your answer. Alright, so we're given the zeros, 5 and 0. We have a minimum value of negative 10. We'll figure out what that means in a second. Find the equation of the problem in factored form and determine the direction of opening. No problem. Minimum value of negative 10. Let's just draw a quick picture. So it's going to look something like this. Parabola has roots of 5 and 0. So we've got 0 here and 5, and a minimum value of negative 10. Doesn't that mean that the parabola has to look like this? The minimum, it has to be a minimum of negative 10. Okay, so if it opens up, it has a minimum. So that's look something like this. So really, isn't this question already answered for us? What's the direction of opening? It has to be up for those reasons because it has a minimum. So let's go right to A. A says find the equation in factored form. No problem. Okay, so we're going to write out the equation. F at x equals a, x minus s, x minus t. We have our s and we have our t because those are just the zeros. That's going to be 5 and 0. So plug that in. So we've got f at x equals a, x, copy the minus, and then put a 5. There we go. x minus 0, which is just x. So I'm just going to rewrite this as f at x equals a x minus 5 times x. Okay, and just as a side note, because we're always getting context, if I were to give you this and say, what are the zeros? You'd say, well, what does x have to be here? 5. Boom. What does x have to be here? 0. Boom. Okay, so bring everything full circle. Now it says find a. So we figured out, well, that's what we have to do to find the equation. We need a, s, and t. So we got to find this guy. Last time we plugged in a point. Here, we're kind of given a point. We're given a hint to a point. We're given a hint that the minimum value is negative 10. What that really tells us is that the y value of the vertex is 10. But what the heck is the x value? So what we're really actually looking for, so we need this point. We have something in for x, and we know y is negative 10. So in order to find this x, we just need to find the axis of symmetry. So I'm going to write our axis of symmetry is, just find that middle point, 0 plus 5 divided by 2, which is 5 divided by 2, which is x equals 2.5. Okay, so this is really 2.5 comma negative 10. So we actually already have a point on this parabola. That's a point on the parabola. Point on the parabola. It's a very special point because it's the vertex, but it's a point. Okay, so we're going to plug in point 2.5 comma negative 10. Okay, lovely. So we have our x is 2.5 and our y is negative 10. So exciting. So instead of y or f at x, we're going to write negative 10. Let's do it. So we got negative 10 equals, instead of a, no idea what that is. So we got to keep it going. Bracket, instead of x, I can write 2.5. 2.5 minus 5 bracket. And instead of x, I can write 2.5. Okay, keep going. So I've got negative 10 on this side equals a. 2.5 minus 5 is negative 2.5 times 2.5. We've got negative 10 equals a, bracket, negative 6.25. Keep it going. How do I get rid of this guy? Well, I've got to divide on both sides. Divide negative 6.5 or 2.5. Okay. Bring it on up here. So we've got 10 divided by 6.25. That's going to make 1.6 equals a. Lovely. There's our a. So let's put it together. So we've got f at x. I'm going to go back to this guy right here, and I'm going to plug in my a now. So I have f at x equals 1.6. X minus 5 times x, and that's my final answer. Now back to B. B said determine the direction of opening. We had said it was up, and look, we're totally right. We're so smart because A is positive, therefore it opens up. Are we ready for one more question? All right, scroll down to this guy here. Let's read it together and we'll figure it out. Okay. Okay, before we get going, I just want you to, we're going to cross out one piece of information to make this question a little easier for the tools that you have right now. I want you to take off, given that the top of the bridge is 4 meters from the surface of the water. Now let's read it. Okay, so a concrete bridge is shaped like a parabola. Perfect, because that's what we're learning about. The arch is 3 meters high at the center and 10 meters wide at the bottom. Determine the equation of the parabola. Okay, the trick to these questions is you have to draw a picture. If you don't draw a picture, you're going to make silly mistakes and waste your time. So first thing you're going to do is draw a picture. Let's deal with the positive x-axis just because we can, and it's going to make for nicer numbers. So we know the parabola is going to look something like this. We're given that the arch is 3 meters high at the center. So that's really telling us this bit here has to be, this highest point has to be 3 meters. So if this is height and we've got distance across, so this is our horizontal distance and this is our vertical, sorry, I forget you can't see what I'm doing. If this is our horizontal distance here and this is our vertical height, okay, so our vertical height is 3. And the parabola is 10 meters wide, which means that we can make this 10 and we can make this 0. So really, we've got a ton of information here. We have the zeros. Let me get this here. We have the zeros, and we have part of the vertex. Let's really quickly find the other piece of this vertex. What is in the middle of 0 and 10? I don't even need to do a calculation. It's 5. So the point that I really have right here is the point 5, 3. So this is a really, really easy question. Okay, come up with the equation of the parabola. Let's do it. So we're going to write out f of x equals a, x minus s, x minus t. Now we should be able, this should be pretty easy for us. So our two x-intercepts are, of course, 0 and 10. So let's throw those in really quickly. So we've got f at x equals a, x minus 0, which is just x, and x minus 10. Beautiful. Okay, we got to solve for our a. So let us plug in for x and y. We're going to use that point, of course, that we have, which is right over here. So we are going to plug in 0.53 for x and f at x. No problemo. So instead of y, what are we going to write? Of course, we're going to write 3. So I'm going to write 3 equals a. Instead of x, we're going to write 5. 5. And then we got 5 minus 10. And now we're just solving. So we got 3 equals. By the way, before we keep going, should a end up being positive or negative? If you said negative, you are right. Why? Because this problem opens down. This is a bridge. This is not a U. All right, so we've got a 5 times negative 5. Okay, we got 3 equals a times negative 25. Let's divide by negative 25. Divide by negative 25. And we've got negative 0.12 equals a. Woohoo. We found our a. Let's plug that guy all the way back into our equation now. So we're going f at x equals, our a is negative 0.12 times x minus 10, and we are golden. All right, if you're confused with any part of this video, just rewind and go back. You've got homework to do. It's right at the bottom. Get it all done. Here we go. Here's the homework. Lovely. Let me just highlight in a different color. Dun, dun, dun. Open up your textbooks. Have fun. Ask the people around you if you have any questions.